This is part of the tutorial for R, and in this tutorial we'll discuss finding p-values. Let's start by reviewing what is meant by the p-value. So let's recall that the p-value is related to hypothesis testing. And in hypothesis testing, when we look for the, let me find the pen here, when we look for the confidence, okay, we have the data, and by the central limit theorem we can say it's going to have some sort of shape like this. Alright, fine. This is the mean. That's part of the null hypothesis. And then we have a test value, and the test value turned into some z's. Of course, z's looks like this. Now when we look at the regular hypothesis testing without the p-value, we set a confidence level based on an alpha. Okay, so if we want 95% confidence level, alpha is 0.05 because that's 1 minus the confidence level, or this would be 95%. Okay, if we want to be more confident, we're down to 99%, and this is really the this would be 90%, and this alpha gives the probability of not making a type 1 error, and a type 1 error means you've rejected a null hypothesis that was true. So what's done at this point is to go up here, let me find a different color, and to find, based on this alpha, the amount of area under this curve, for example, let's say like that, that might correspond to an alpha of 0.05. In other words, as you know, under this whole curve the area is 1, so total area is going to be 1, so we want the area here that corresponds to the alpha. Okay, and then, okay, from this, we know this area, we back it out and we find some z alpha that corresponds to this area, and we compare it with the z value for the test. Now someone might say 0.05 is not good enough, I want 0.01, in which case it could be over in a little bit. Let me find a different color here. They might be over here to the point where they unmask the z test value, so that for this case, for the 0.05, the null hypothesis is rejected, but here for the 0.01, the null hypothesis then is accepted. For the p-values, we look at it a little bit different way, which actually gives a lot more flexibility than this, than just even picking these standard alphas. Okay, sort of remembered that previous scenario, and we're looking here. Let's go back to our data again, poorly drawn as usual. Here's the z value. Okay, and here is our z test value. And instead of hardwiring in the alphas, we look at the area starting with the z test value. We don't find a z alpha, we look at the z test value and we find the area behind that. Of course, this is probably a t-distribution, it's pretty heavy in the tail. But so we're looking for this probability, this area out here. Okay, that's easy enough to find, and we say this is the probability that this z test value or something more extreme would have been found if the null hypothesis were true. That's all it says. But then once you have that p-value, you can decide. Alright, say this p-value is 0.03. Right, then you can compare it to what you would think the alpha should be. These are published often in a paper. Okay, so if you say, if I pick the alpha to be 0.05, in other words, I want 95% confidence that I'm not making a type 1 error. Alright, for the 0.05, I could say, well, the p-value is less than that alpha, so here's your alpha 0.05, and it's less than that, I'm sorry, went the other way. The p-value is less than that alpha, then I would say okay, I'm going to go ahead and reject the null hypothesis. Or somebody else might say, I want a 0.01. I can compare that to 0.03 in this case. They'd be accepting it. So after you get the p-value, then you can make your judgment as to whether to reject or accept the null hypothesis, and you can go through the procedure instead of someone telling you, okay, we rejected it based on, some value. So that's what we're looking for in the p-value. We're looking for the area under the curve that starts at the z-test value and goes out towards the tail. So when we go to find the p-values, we have to use a distribution if the sample is large enough, and put that in quotes, and we'll go ahead and use the normal distribution. And that's what I'll show in the first example. So what I've done is I have attached to R a data set called warp breaks. It has to do with yarn breaking in some weaving situation. Okay, so here's the wool. So it's a certain kind of wool under a certain tension, and they're looking for the breaks in the wool. Okay, just for purposes of discussion, we need to have a null hypothesis, and let's say the null hypothesis says that let me write it as a null hypothesis, so would be that mu is 22, just for purposes of discussion. In R, once you get the data in, it's actually just a one-liner to find the p-value, and it's very conveniently written here as, remember, norm, whoops, I have the pen for some reason. Okay, let's see if that works. Okay, the norm in R means the normal distribution, and there are these letters placed in front of it, some prefixes. The D gives you the values, doesn't matter where it's located here, it gives you the value, the density value right here. That's what D does. Okay, what does P give you? It gives you the probability, it gives you the area under the curve. So and then p-value, same. Okay, so this is what I use right here, the p-norm. And now in this case, what I've done here, because this is the way I like to do things, and you don't have to do it this way, but this is the way I do it, I specify everything right at the onset. Here's the number, all right, the sample mean, which means I just take the mean of the work breaks and get it, sample standard deviation, SD of the work breaks, just get it. Also, I'm looking at the breaks in that data set. And the null hypothesis criteria I put as mu naught equals 22. Okay. Now, from that, I calculate the z-test value. In other words, I've taken and made the z-scores before I even start. I just decided to do it this way because I like to have all my data set out and named, so that I keep emphasizing this, so when you go back, you can see what you've done. This is just nice practice to do it that way. It works better. So now that I have the z-value, all I wrote here, p-value equals p-norm, and I give it, all right, there's a question. If you have the z-test value as negative or positive, you really want, all you want is the area, and that's going to be a positive value. One way to get it is to give it the absolute value of z-test, and then just say the lower tail equals false. By lower tail, which is equals true as the default, what you're going to do is get the positive value up here. And okay, so here you go. Lower dot tail, remember lower, you have to have the dot in the middle of it. Lower dot tail equals false, capitalize false. The other way to do this is to give it the, you can give the standard deviation and the mean, you can give it right here in p-norm. Norm will take a different standard deviation and mean, then mean of 0, standard deviation of 1, although those are the defaults. Anyway, that's it. So it's just a one, okay, it's a one-liner. Okay, let me do this in real time in R so you can see how it's done. So first I attach a data set. In this case I'm attaching warp breaks. And I want to look at warp breaks because I'm going to select a variable from there, and and I want to make sure I have the spelling right and the capitalization correct. So I type warp breaks, and it gives me everything in that data set. See, there's 54 values. I'm going to go back up here and find where this starts. Okay, here it is. I had to change the font. Let me show that and show you how I did that. Okay, go over here to Edit, and you see GUI Preferences, and now you can set it. It's going to come up with a size 10 font. If you don't like that, you can set it to something larger, which I usually do. It looks like the scroll bars don't fit a larger font, and that was my problem a minute ago. But if you don't like that little tiny typing on the screen, you can set the font to a larger size. Okay, we'll just leave it as it is, and again, it's under Edit GUI Preferences if you want to change that. Okay, so here I am, and I'm going to look here at the variables, wool, tension, and breaks. And what I'm looking at is the number of breaks, and that's what I'm going to do, is find the p-value for the number of breaks. Okay, so I see how it's spelt and everything. I can, and I said my null hypothesis was going to be 22, so I'm going to type these values in, and I'm going to give them names. The number, which is the number of data values, is 54. To find the sample mean, our command for mean is just mean. And I can give the name of the data set, $, and the variable. Now, I typed it wrong, but that's okay. Everybody makes mistakes here. So you go back, and I had a C in it, which wasn't right. Then I want the standard deviation for the sample. SD is standard deviation. Again, I'm going to type warp breaks. And I should have used the up arrow, which might have made it easier. And now I know the test value. The null hypothesis value of the mean is 22, so I'll put that in here. Now I need to find the z-value for the test. And how do you find z-value? You take the mean, spelled correctly, you subtract, or the z-value, you subtract the mean, you divide by, in this case we're dividing by the sample standard deviation over the square root of n, which is another way to get the standard deviation for the population, because the sample is large enough. Okay, there we go. Now we have our z-test value, and I want the p-value. I give it a name so I can type it out. You don't have to if you just want to get it for one time, but I'll give it a name. And now its norm is the normal distribution. P gives you the probability, and conveniently that's also what we're looking for, the p-value. Absolute value of z-test, this is how I do it. And then you set the lower tail equals to false. Remember, false has to be capitalized. And now I'm going to type it out. And there we go. So it looks like for 0.0003, for an alpha for any alpha that we would typically pick, we would, in this case, reject the null hypothesis. The second example in the written tutorial, uses a t-distribution. So we use a t-distribution when the size of the sample is smaller. And I'm going to go ahead and just do this example here. What I used was the benzene example from the text that's on page 351. So I'm going to make benzene a data frame. So remember, data dot frame. And all I care about is the benzene content and some stack testing. So here we go. It's a numeric value, and I set it to 0. This is a little review of how to create a data frame. Also, you better spell it right. So I'll put the E on the data frame. Okay, so that's all I have is one variable in there, and I'm going to use fix to create it. And the reason I use fix is because I can fix my errors easily if I make them. So when I hit fix, of course, you get a data window. an edit window, and you can just start typing the values in there. I'll type a few and then I'll go and type them by myself so that the boredom factor will not get too big. So you just go down here and type in all your values. I'm hitting the down arrow as I go. 0.36. Okay, I'm going to stop. I'm going to stop the video for a minute and fill in the rest of the data values. Okay, so I entered all the data values, and if I want to check them, which is a good idea, we just go benzene. And there's a list of them, and we can check them against the value. Now, I really don't have to do all this, but I like doing it. So the number in this data set is 20. You can see that from right here. Sorry. Sample mean. Remember, just take the mean, give it the data set. There's only one thing in this data set, so I can just call it benzene. It works. And I can get the standard deviation here. I'll just call it S. And I need to know my test value, and in that problem, the test value, said by, I guess, Fish and Game or whoever said it, the limit should have been 1. So I use it 1. That's why I put the 1 in there from the problem. And now I want the t-test, okay, instead of the z-test value. And it's the same equation. Sample mean minus, or the value, in this case the mean, minus the population mean, S, which is the standard deviation for the population, or for the sample, divided by the square root of n. Okay, there's my, okay, now what do I do? Well, I could go back and fix this one, which I'll do that, just for consistency, and now I go back and find t-test, and t-test should work. I had a spelling error. Okay, the p-value for the t distribution is p, and t meaning t distribution, and I give it the absolute value of the t-test. Remember that capitalization does count. Now, for the t value, you need degrees of freedom. Okay, that was the t distribution is based on degrees of freedom, so I have to give it degrees of freedom here, so let's call it df is the parameter, and that's n minus 1. I can just put the calculation right there. Lower tail equals false because I want a positive value. I don't have to deal with it. Oops. There we go. Should work. And I'm going to print it out. Well, that's pretty high. So, actually, I think I made an error. But anyway, that's a calculation, and that's what you would submit for homework. To review on that, if you want to submit this for homework, you might check it out a little bit, but if you want to submit it for homework, you just go to File and go to Print, and you'll print out this list of commands, and that's what you send in. Okay, when you do this, sorry for that little keyboard there. When you submit the homework, again, I'm not looking to see that you never made an error in typing. That's ridiculous. And also, what happens if your value is off? Well, if you've done everything right up to this point, probably nothing. This is a class where you have to learn the procedure. So I want to see that your procedure is correct.